Okay, so here we have an equation in what's called slope-intercept form. And the reason we try to manipulate equations so that they end up in this format is that once we get it in this form, once we get the equation in this form, it's super easy to graph because we know the y-intercept, which is a point, and we know the slope. Okay, so if you have an equation that's something like y equals 2x plus 1, it's very easy to graph because you know the y-intercept is 1. It intersects the y-axis at the point 0, 1. Okay, and you also know the slope is 2, which 2 expressed as a fraction is 2 divided by 1. So on the coordinate plane when you're graphing from your original point, which is the y-intercept, you go up 1, 2, over 1, and you have your next point. And remember, once you have 2 points on any graph, you can go ahead and draw that line. Close enough. Okay, so when the slope is a whole positive number like 2 or 5, 6, whatever, if it's a whole positive number, it's pretty easy to graph. You just go up that number, in this case 2, and then over 1. But sometimes it can be a fractional number or a negative number as well, and it's the same concept, just one additional step. So let's do y equals 1/2 x plus 2. Well, in this case, let's go ahead and erase our first line. In this case, it's the same as with the previous equation. We know what the y-intercept is. It's going to be the point 0, 2. Okay, 0, 1, 2. That's where that line is going to intersect the y-axis. And now we have a slope of 1/2. So if you remember when it was 2 over 1, we went up 2, over to the right 1. And another way of expressing that could be written as rise over run. You may have seen this when dealing with slope before. Rise is your change in y. Change in, that little sign just means change in y over change in x. And these two things mean the exact same thing. Rise over run, change in y over change in x. And you may have seen all that before. So if our change in y for 2 over 1 was up 2 because the numerator of this fraction, 2 over 1, the numerator is 2. That's a positive 2, so you go up 2. And then the denominator is 1, so you go over. It's a positive 1, so you're going to the right 1. But with this fractional slope, which is 1/2, it's the same exact thing. So now, instead of going up 2 over 1, we're going up 1 over, again to the right because it's positive, 2. So, going back to our line here, we started at the point 0, 2 because that's the y-intercept of this equation. And then we're just going to go up 1 over 2. Up 1 over 1, 2. There's our next point. Okay, and again, if you have 2 points, you can go ahead and draw a line, but let's say, like me, you're not super good at drawing straight lines, so you just want to do another point, okay? You go up 1 over 1, 2. Up 1 over 1, 2. Same thing. Any fractional slope just tells you rise over run. Okay, so now that we have a few lines, we can go ahead and plot that. Close enough. And there you have it. So now let's talk negative slopes. Let me erase our work so far, and then we'll just do a simple line with a negative slope. So let's go y equals -3, right? X plus 5 this time, okay? So first, as we know, we want to get a point on the grid. So we know the point 0, 5 is going to be a point because that's our y-intercept. So 0, 1, 2, 3, 4, 5. We know that's a point on the graph. And then our slope is -3. So if you remember, slope is rise over run. And -3 is the same as -3 over 1, because any number divided by 1 is going to be that number. So when you put it in fractional form, if it's a whole number, just put a 1 underneath it. So remember, 3 is rise, 1 is run. So from our point, our y-intercept, point 0, 5, we are now going down 3 instead of up 3, because if it's a positive number, we would be going up. Positive slopes should look like that. They're always going in a positive direction. They can be very small in a positive direction, but they're always going. Or they can be very steep in a positive direction, right? But they're always going in a positive direction. In the same way, a negative slope, when you have the equation y equals mx plus b, if that m is negative, then it is going downward. The line will be going in a downward direction because your slope is negative. And again, it can be not very steep, or it can be very steep. But if the slope is negative, it will always be going in a downward direction. And you don't even need to know that to plot the graph of this equation. It's just helpful to know to check your work later on. So we know rise over run, we're now going down 3, and we are still going over 1, okay? And that is over to the right. To the right again, just like with the positive. I know with the slope being negative, you might be tempted to go, well, it's a negative slope, so let me go down 3, and then over to the left 1, because that's negative, but that would actually represent the fraction -3 over -1. And as you know, if you divide a negative by a negative, well, that's actually going to be a positive. So going down 3 and to the left 1 would actually cancel out those negatives, and that would be just the same as graphing a positive slope. So we'll do a few more examples if that kind of confused you, but just know that if you have a negative slope, you're going to be going down from your point, down, and then you're also going to be over still to the right, okay? So let's go from our point. Our rise over run, our slope is -3 over 1. So we're going to go down 1, 2, 3 over 1. We could draw the line because we have 2 points, but let's make a couple more dots, a couple more points on this line. So from that point again, down 1, 2, 3 over 1, down 1, 2, 3 over 1. Okay? And we could draw that line. Before we do, though, I did say we'd come back to this, so let me just explain something real quick. What if we have a slope of -3 over 1? Well, we just have the one negative sign, right? We just have the one negative sign. If it were two negative signs, then it would cancel out and actually be a positive slope. So here, what we've been doing, didn't mean to erase that. Here, what we've been doing is applying the negative to the top number. So what if we applied that negative instead to the bottom number? So what if we went up 3, and that's the same thing as +3, and then we went to the left, which is the same thing as negative. We went to the left 3, left 1, because 1 is in the denominator, and that's the same as a negative 1. Well, then we have positive 3 over negative 1, and there's only one negative. They're not going to cancel, so your slope is still negative 3. So let's test that on a graph. Starting back at our y-intercept here, at this point here. Okay. Starting here, let's go up 3, up 1, 2, 3, and now to the left, 1, left, 1. That's a point. And is that still a point on that line? Yes, it is. As you'll see, we can go in either direction as long as we keep the slope negative, basically applying that negative to either the numerator or the denominator. And let's see if I can draw this line. All right, so let's put these into practice. We have y equals 5 over 3x minus 9. So right off the bat, we know we have a y-intercept, so let's go ahead and do that. It's going to bring this first point down here at 0, negative 9. And then we have a fractional slope of 5/3. So remember, rise over run is going to be up 5 and over to the right, because we don't have any negatives here, 3. So up 5 over 3. So from our point down here, 0, negative 9, we would go up 1, 2, 3, 4, 5. It's already over 1, so we would go over an additional 2, 3. There, we went up 5 and over to the right 3. So we have y equals 4/5 x minus 7. Again, we have our y-intercept, so that's our first point. And then we're going up 4 to the right 5. Up 1, 2, 3, 4 over 1, 2, 3, 4, 5. I think I counted that right. There we go. Here's a negative slope. All right. So this one is y equals negative x minus 6. So first step, when your equation's in the format y equals mx plus b, slope-intercept form, the first thing you're going to want to do is to plot that y-intercept, which is negative 6 here. And then our slope is negative. There is an assumed 1 here, okay? Because negative 1 times x, well, no matter what x is, that's just going to be negative x. So we don't really have to write the 1, but it's assumed. So we have negative 1 over 1. Okay, so we can either, if you remember, we could go down 1 and then right 1, or we could go up 1 and apply that negative sign to the denominator and then go left 1. And that's still going to get us the same graph. So let's actually try both ways just to show you that it would still work. So if we went down 1, right 1, well, we would start at the negative 6. We would go down 1. Right 1 would get us right there. Okay? Just get a mental picture of what that line looks like. But if we apply the negative to the denominator and we go up 1, left 1, well, from our y-intercept, from the negative 6, we would just go up 1 and then left 1. That line looks exactly the same. We just kind of flip-flopped it. But notice the points all along this line would just be either going right 1, down 1, or up 1. I'm sorry, excuse me, got confused there. Notice each point would either be going down 1, right 1, or up 1, left 1. And either way would be correct, as long as you just have one negative in there.